Alright, we're going to sketch this. The first step would be basically to find your x and y intercepts. I did not show the work here, but there's only one right there in the middle. That's your x and your y intercept. Then we want to find asymptotes. When you set the bottom equal to 0, there are no vertical asymptotes because you cannot set the bottom equal to 0. There's no slant asymptotes because the top degree is smaller than the bottom degree, so there's no slant asymptotes. There is a horizontal asymptote because when you take the limit as x approaches infinity or negative infinity, when you take this equation, you divide by x squared, x squared, x squared, you end up with this. And when you plug in infinity, you end up with 0 over 1 plus 0. So you have a horizontal asymptote at 0. As you can tell from the graph we'll be sketching, you have a horizontal asymptote meaning it approaches 0 on the ends. You find your first and second derivative. That would take you a little bit. That probably took a little while. When you set this equal to 0, those two gave you positive negative 1. The bottom is not possible still. When you do your second derivative, when you set both of these equal to 0, you got 0, positive negative square root 3, and the bottom again still isn't possible. So you didn't even have to worry about setting that equal to 0 because it can't be done from the beginning. You can tell that. So you got all the possible points of inflections, all your critical numbers. You make your table. As you can tell, negative square root 3, negative 1, 0, 1, and square root 3. I basically use all these values to make my table. I'm going to plug in values to f of x. So I get my coordinates. This is a coordinate, 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 coordinate. I do my first derivatives for everything. Now, with my first derivative, all I care is it positive or is it negative? I don't care about any, or 0. So positive, negative, or 0. For my second derivative, same thing. All I care if it's positive, negative, or 0. Now, when I plug in and find these values, do you understand I'm plugging a value on this interval? For this one, I plug in a value on this interval. For this one, I plug in that value, because that is actually a point. So for intervals, you plug a value on the interval. For the where x equals, you plug that value in. And then from reading the table, this is saying my first derivative is negative and my second derivative is negative, meaning it's decreasing and concave down. This one's saying my second derivative is 0, and it changes from negative to positive, so that verifies it actually is a point of inflection, which I could write the coordinate right there, which I did not write. I probably should have wrote the coordinate of my point of inflection. That's one thing I forgot to write in here. I should have my coordinates for these. See all these are lacking the coordinates? I probably should have wrote those in. The coordinates are these right here. And let's just say you look right here. It's going from positive, meaning the first derivative positive, the second derivative is negative, so it's increasing, and negative means concave down. Why do I know, for instance, this one's a relative max? Because my first derivative is 0, and it changes from positive to negative slopes. Or by second derivative test, I notice that the second derivative is negative, meaning it's concave down. That's why it's relative max. I plot all 4 coordinates. 1, 2, 3, 4, 5, 5 coordinates. I plot all the green dots. And then I look at my information, decreasing and concave down. So from here to this green dot, it's going to be decreasing, going downhill, and concave down. This one says I'm decreasing but concave up, so I know I have to kind of have a curvature up a little bit. And then for this, from this green dot to this green dot, you know it's increasing and concave up, so it has to go like this. And if you slowly look at each step, you'll notice by what they say like decreasing concave down, it means it's going from here to here down, and it has to have a concavity down. You just got to use this table to help you sketch it properly. This table is very organized if you can make it. Be careful with your first and second derivatives. Make sure you find your asymptotes. It will take you a while.